All right, so matrix operations. A matrix is just an organization of numbers or elements. They don't necessarily have to be numbers. And you draw a matrix inside of these square brackets. Okay, got to be the square brackets. Can't just be two straight lines. Two straight lines means something else when you're dealing with matrices. So make sure your brackets are square when you draw a matrix or you write out a matrix, okay? A matrix has what's called elements inside of it. And I'm going to use letters for this first one. A, B, C, D, E, F. All right, so here we have a matrix. It has 6 elements in it. Those elements are in certain positions. This element A is in the first row, first column. Okay. Element B is second row, first column, second row. Or back up. First row, second column. First row, third column. That's how you're going to go row by column. All right. The dimensions of that matrix. Dimensions. This is important. Dimensions are important because that tells you whether or not you can do some of these operations. If the dimensions match, that means you can do certain operations. If the dimensions don't match, that means you can't do some operations, but in some cases, when we talk about matrix multiplication, you don't want them to match perfectly all the time. You need certain parts of them to match. Dimensions for a matrix are named by row, by column. Rows, side to side, columns, up and down. Okay. This one has how many rows? 2 rows. How many columns? 3 columns. 1, 2, 3. So this is what we call a 2 by 3 matrix. Okay. Got to be able to name the dimensions of a matrix because that is important as far as whether or not you can even do an operation with 2 matrices. So you got to be able to name the dimensions. Remember, it's row by column. How many rows? How many columns? Rows, columns. Make sure it's row by column. All right. Let's get into the easy thing first. Add and subtract. When you add and subtract matrices, well, that's one matrix plus or minus another matrix. What you have to have is the dimensions must match. If they don't match, you can't do it. It's undefined. Okay? So, example A. Let's say we've got this matrix 3, -5, 6, 4, -2, 11, plus another matrix, -12, 6, -4, 10, -8, 4. Okay? The first thing you should check before you start doing any work, mathematical work, is what are the dimensions of these 2 matrices we're trying to add together. What size is this first one on the left? 2 rows by 3 columns. What size is this one? 2 rows by 3 columns. If you're asked to add or subtract matrices, the dimensions have to be exactly the same. 2 by 3 adds to a 2 by 3. You cannot add a 2 by 3 and a 3 by 4 together. They have to match perfectly. The reason they have to match perfectly is because the way you do matrix addition and subtraction is element by element. Okay? And when I say element, I'm talking about this 3 is the element in the first row, first column of matrix, the left matrix. The matrix on the right, what's the first row, first column element? -12. Those 2 go together. Okay? It matches up piece for piece. I usually don't do matrix addition in the calculator just because I can just do it quicker just doing regular math. But I will show you how to do this. Okay, so we're going to add element for element. So 3 plus -12, -9, and then -5 goes with what? 6. Negative 5 plus 6, 1. 6 plus what? Negative 4, match it up, that'd be 2. 4 goes with 10. 4 plus 10 is 14. Negative 2 goes with negative 8, that'd be negative 10. 11 plus 4 is the only thing left. So 2 by 3 plus 2 by 3 gets you a 2 by 3 with addition. Same rules for subtraction. We'll do one in a second, but that's our sum matrix is the correct word for that, but that's the answer, is that matrix. Okay? Show you with a calculator how you can do that with the graphing calculator. Not that I usually don't, because it takes longer to put it in than it does just actually do the work. But if it were like weird numbers in like fractions and stuff, and you didn't want to have to do those individually, you can get your calculator to help you. So with the graphing calculator, to get to a matrix with the calculator, if you look in written in blue right above the buttons there, if you go down 1/4 button down is the X inverse button. Above that is a blue word matrix. So that means we got to hit second and then the X inverse button to get to the matrix menu. Second, and then that one that's highlighted in red right there. Okay, and that gets us here. You may have some stuff written here. It may have like a 2 by 3, 3 by 4, something in your calculator. It's okay if it does, not a big deal. Okay, these are just the names, and it names them by letter. Okay, what we want to do is edit a couple of them. So I'm going to go press the right arrow key or the left arrow key. It doesn't matter. I'm just going to move over to edit, and I'm going to pick a matrix to edit. I'm going to pick matrix A, and then just hit enter on that, and you should get here. And this is where we set it up. What size was the left matrix in the example we just did? 2 by 3. So we're going to put 2 rows, 3 columns. 2, press the right arrow key, 3, and I hit enter, and oh, look at it. It shifted it to make that size matrix. Check that to make sure it looks like the one you've got as far as the size goes. Then just put your elements in there just like you had. So we got 3, enter, negative 5, enter, 6, enter, 4, negative 2, and 11. Make sure you're very careful with signs because it's so easy to make that mistake and not type that in correctly. Okay? It goes across the rows to put them in. That's the way it does that. Okay? So there's matrix A. We need a matrix B in there. So I'm going to hit second, quit. That gets me back to the regular calculator screen. Second matrix. I'm going to go to edit. And I've already put one in A. I need to put the other one in either B or C or anything else. Second. Okay. Go back to the matrix menu. And I'm going to pick matrix B. Under edit. And it's a 2 by 3. And I'm going to put in negative 12, 6, negative 4, 10, negative 8, and 4. It's 2 by 3. Make sure everything's where it should be. The elements are in the right spots. Then I'm going to hit second, quit. Get back to the regular calculator screen. Now I'm going to get it to do that operation. So kind of see why I don't usually do these with the calculator. It's faster for me to do them without it. It's just math. It's just add and subtraction. To do the math, you go second matrix, and then you pick the name of the matrix you put in. So I'm going to put A, hit the plus sign for addition, second matrix, and then B, and that should be on your home calculator screen. And then all I do is hit enter, and it should punch out that same matrix that we did by doing it just normal stuff. Okay. Yeah. Thank you. Okay. All right. Putting them into the calculator, not as useful for addition and subtraction as it will be for multiplication, but it does get you the practice of putting one in. Okay. Multiplication is going to be very useful. Not so useful for addition and subtraction because we can do the math quicker. All right, let's do this one. Take the same two matrices, 3, -5, 6, 4, -2, 11, minus -12, 6, -4, 10, -8, 4. Same two matrices. Nothing's changed as far as the numbers go. We're just subtracting instead of adding. Select the name first. Just get there. Second matrix. Plus. All right, subtraction. We've already got those entered in our calculator. We could do that subtraction really easily just by going to our calculator and getting matrix A minus second matrix B. And we crank that out. We get 2 by 3 matrix back. Generally, if it's a fresh matrix, I don't tend to, again, do these with the calculator. I'm quicker at just saying -3 minus -12. Well, not -3. That's +3, wasn't it? I wanted it to be the same. 3 minus -12 would be 15. -5 minus 6 would be -11. 6 minus -4 is 10. 4 minus 10, -6. -2 minus -8, +6. 11 minus 4 is 7. And there I have that same solution matrix to that. Okay. So in order to add and subtract matrices, what do they have to be? Same size. Okay. If they're not the same size, for example, just take 1, 3, 4, 5, 6, 7, 8. What size is this first one? 2 by 3. What size is the second one? 2 by 2. If they don't match in size, it's undefined. Okay. If you tried to do that in your calculator, you put both of those matrices into your calculator and try to get it to subtraction, it's going to give you a dimension mismatch error, meaning that the dimensions of the matrices don't match up, so you can't subtract them. Okay. So that's the rules there. If the dimensions are not the same, it's an undefined operation because they're inside of a matrix. So they don't happen a whole lot with what you're doing, but make sure you know that's what that's called. Okay. All right. Let's go to the next easiest thing. Scalar multiplication. Scalar multiplication, it's not distributive property, but it works a whole lot like it. Okay, so that's what I want you to think of. It's like distributive property. Okay, scalar multiplication means you're taking a matrix, and let's say, for example, it's this one: 6, -5, 8, 11, 7, -2. What size is that matrix? Say it again. 3 by 2, 3 rows, 2 columns. Okay, and a scalar multiple or a scalar multiplication is just taking some number and multiplying that entire matrix by it. So it might be written like that. 3, and then a matrix. All that means you're doing is taking every element of that matrix and multiplying it by what? 3. Again, something I normally don't do in the calculator. 6 times 3 is 18, negative 15, 24, 33, 21, negative 6. The matrix doesn't change sizes. Get you back a 3 by 2, just like you started with. The scalar just multiplied to everybody on the inside. That's all that's happening there. Calculator-wise, you put this matrix in, and then when you go to do that scalar multiplication, you say 3 times the name of the matrix you put it in if you want to use a calculator to check yourself. Okay. But it's the easiest stuff. Okay. Let's scroll back up. We still see that. All right, example E. Let's say we had this matrix 3, negative 5, 6, 4, negative 2, 11. That should be familiar. That's from example A and B. It's the same matrix. It's that left matrix that we had there. Let's do a scalar for that with a fraction, because it looks like it's tough when it's a fraction. So taking that and doing what with the 2/3? Multiplying it to everything. Okay, so we got 2/3 times 3, which is not terribly difficult. That'd be 2, right? Negative 5 times 2/3 would be negative 10 over 3. 2/3 of 6 is 4. 2/3 times 4 would be 8 over 3. 2/3 times negative 2 would be negative 4 over 3. And 22 over 3. Sometimes we get a little nervous when it's fractions and we want to check ourselves. So this is where maybe a scalar multiplication with a calculator is helpful to check yourself. So with the calculator, I know that that's matrix A. That's the one I put in matrix A. I'm just going to take 2/3 times second matrix A. And when I hit enter, my calculator throws out all these decimals, which is not what I want. Okay? How do I change decimals to fractions with the graphing calculators? Anybody know already? That's it. Math, enter, enter. Math, and then hit enter twice. And boom. Does the nice improper fractions for you there. If it can be converted into decimals, from decimal to fraction, it will do that by hitting math, enter, enter. Again, scalar multiplication, not something I usually have to put in the calculator to do, but sometimes it's good to check. Okay, so it shouldn't be a big deal. All right, now let's combine that with what we just talked about with examples A, B, and C. Let's say we had this matrix 4, negative 1, 1, 0, 2, 7 with a 2 out in front, plus 8, 3, negative 9, 5, 3, 20. Thinking about just regular arithmetic, the way you've been doing math for several years now, what should happen first in this problem? That scalar multiplication. Multiplication, order of operations. Please excuse my dear Aunt Sally, Tim Doss, whatever, whichever way you remembered that. Parentheses, exponents, multiplication, division, left to right, and then addition, subtraction happens last, left to right. So that multiplication should happen first. So when you do that, then you're going to add across. Can these two matrices even be added? Yeah, we got, what size is this one? 3 by 2. This one's a 3 by 2. So we're good to add them. So I'm just going to go ahead and multiply. 2 times 4, 8 plus 8, 16. Okay. 2 times negative 1, Negative 2 plus 3, 1. 2 times 1 is 2 plus negative 9, negative 7. 2 times 0 plus 5, 5. 2 times 2 plus 3, positive 7. 2 times 7 plus 20, 34. And there we have scalar multiplication combined with addition or subtraction. Again, you could do that with the calculator by putting in this matrix and then telling it to say 2 times matrix A plus matrix B. You could do that. But in the time it takes you to type them in, it's not hard math. So it's doable to just do it one piece at a time, one element at a time if you want to do it that way. Okay? All right. Now, kind of in the same area of matrix addition and scalar multiplication and all that stuff, comes up this thing called matrix equations. And matrix equations, this is not systems of equations. I got to kind of preface that it may look like it may be systems, but it's not. They may have more than one variable there, but it's just regular equations that are kind of tucked inside of matrices. Okay, so we just got to pull them out and then work the problem. Okay, so let's get an example. I think you'll see what I'm saying. Here's the first matrix: 3x, 5, 7, negative 2y, plus another matrix, 8, negative 2, 4, and 3. When you add those two together, you should get this third matrix, 11, 3, 11, negative 9. Okay? Now, it's got an x and a y in it, but don't get that confused with systems of equations. That's kind of why we took a test last week to kind of end that for the time being, and then go to this today. It's different. Okay? Now, when we think about matrix addition, what elements go together for this problem? So what 3x is the first element, first column, first row. What goes with it? The plus 8, right? What should that add up to be? 11. That's the equation we're pulling out. Is you're getting 3x plus 8 is equal to 11. That's the equation that you're pulling out of the matrix. Okay? 3x plus 8 equals 11. That's a pretty 7th grade-ish equation to solve, right? How do you solve that? Subtract 8. 3x is equal to 3. Divide by 3. And x equals 1. That's not x being 1 as an ordered pair. It's just x. It's just the variable. Okay? What's the equation for the y? There you go. Negative 2y plus 3 equals negative 9. How do we solve that? Subtract 3. Negative 2y is equal to negative 12. Divide. Positive or negative 6? Positive 6. And then you can go back and you can check that in the problem here. 3 times 1 is 3 plus 8 does give me the 11 in the right element. Negative 12 plus 3 does give me negative 9 in the right place in the matrix. So matrix equations, not incredibly difficult. You just got to kind of decode what's going on there. They can make them a little bit more difficult by taking a matrix and dressing it up a little bit with some multiplication. Let's say we had this 5x, negative 2, 6, negative 4, 3, 7, negative 5, negative y. So a 2 by 2 and a 2 by 2. That's legal to add together. But then they do this. They put big parentheses around that addition of those two matrices and put a 3 out there. So that kind of steps it up a notch. So looking at that, what would be the equation to find x? Close. All right, there you go. 3 parentheses 5x plus 3 equals negative 21. Because that 3 parentheses is around everything here. So it's like a scalar multiple. It's going to do what to everything on the inside? It's going to multiply. So does this say multiply everything that goes with the x by 3? Yeah, that's what it's distributed properties. Remember, we were thinking about it as being distributed property. So if we do that, 15x plus 9 is negative 21. There are other ways to solve this equation. You don't have to do it that way. X equals how much? Negative 2. X equals negative 2. What would the equation be for y? So 3 times negative 4. Do I close my parentheses there or not? No. Subtract y, then close my parentheses. Equals negative 24. Good job. What would be an alternate way of solving this that's different than the way I did this one? Yeah. I divide by 3 there. I don't have to distribute and then end up dividing by 3 at the end. Just got to, because it's multiplying to everything, I can do that. Next step, add 4. And y is positive 4. All right. Question about matrix equations. They can get bigger than that. If you got larger matrices, you might have more things to get together, but it's the same concept though. Find the variable they're wanting you to find and then look for the elements that are in the same spot. That's all you got to know. Which one? We'll get it after a while. That's way back. Okay. I divided on it on both sides. You could. I'm just showing you that you could distribute or do it this way. It doesn't matter which way. They're both legal ways of solving that equation. All right. Let's look at the last thing, which is multiplying matrices. Multiplying matrices is different from adding and subtracting matrices. It's different from scalar multiplication. Okay. Multiplying matrices, just because the matrix, each matrix has the same size doesn't mean it's legal to multiply them. Okay. For multiplying matrices, you got a left matrix and a right matrix. And, you know, when we're doing regular numbers, does it matter which one's written first? If I say 3 times 4, the answer is 12, right? If I say 4 times 3, the answer is still 12. It doesn't matter what order you put it in. With matrices, it does matter. It's not commutative. Multiplication of matrices is not commutative. I mean, you can't change the order. Order's got to be the same, okay, as the way it's written. So we have a left matrix and a right matrix. What has to happen is, how do we name the dimensions of a matrix? Row by column, okay? So the left matrix has a certain row by column size. The right matrix has a row by column size, okay? Those must match. The columns from the left matrix must be the same number as the rows from the right matrix. Columns on the left matrix must match the number of rows on the right matrix. So being able to name those dimensions is important, and getting them in the right order so that you can know if you can even multiply things together. For example, if the left matrix is a 2 by 3 and the right matrix is a 3 by 4, can those two be multiplied together? Yes, these match. Here's the neat thing, or neat property, it does this every time. When you multiply those together, the size of your answer is a 2 by 4. That's where that's the size of your answer is going to be match the rows from the left and the columns from the right. Those two things in the middle has got to match, though. Match, you can't do it for multiplication. Okay. Let's get an example. Two, -5, 6, 1. 7, 6, 4, -5, 3, 1. All right. What size is the left matrix? 2 by 2. What size is the right matrix? 2 by 3. Do they match? Yes. So can we do that multiplication? What size will our answer be? A 2 by 3 and. Now, matrix multiplication, it's a little more complicated than addition and subtraction. It's not element for element because it doesn't match up, right? So what we have to do is take this row times this column and then add the results. So I take 2 times 7, it's 14, plus 5 times -5. 5 times negative, or -5 times -5 is 25, plus 14 would be 39. And then I do the next element in the first row is take this first row times the second column. 2 times 6, -5 times 3, and then add those up. 12 plus -15 be -3. And I'm taking first row times third column. 2 times 4 is 8. -5 times 1 is -5. 8 plus -5 is 3. Okay. That gets me my first row of elements. Second row, I take the second row times each column, and add up the results, and that's going to give me each element. 6, 1 times 7, -5. So 6 times 7, 42. -5 times 1 is -5. 42 plus -5, 37. And then I'm taking this row times the second column. 6 times 6, 36. 1 times 3, 3. Add them together, 39. Second row times third column. 6 times 4, 24. 1 times 1 is 1. That'd be 25. Now, That's a lot of operations and a whole lot of places you can miss a sign, or just miss add, or miss multiply, or maybe mix a number up. Do it backwards. So matrix multiplication, yeah, it's great to be able to do it by hand. I've done a whole bunch of these. I'd hate to put a number on it. How many I've had to do without a calculator. I don't expect you to do that without a calculator. You can use a calculator to do that. To do that, you're going to put those matrices in to your calculator. Let's go through that one more time. Second matrix. We're going to put a new one in. Where do we have to go? Edit. So we're going to put those same two that we just wrote down in here to make sure I'm right. That's a 2 by 2 for the left one. 2, -5. Oops. Let's type it in right. -5, 6, 1. Okay. 2, -5, 6, 1. That's matrix A. That's where I put that. Take it, quit. Go back to matrix. Go to edit. I'm going to go to matrix B. It's a 2 by 3. This one happens to already be a 2 by 3, but it doesn't matter. I'm just going to go across there. 7, 6, 4, -5, 3, 1. Make sure you got all your signs the same as what we wrote down. We got matrix A and matrix B. It is, make sure you remember which one is the left matrix and which one's the right, because it's not the same. If I turned this around and did B times A, is that even legal? It wouldn't match up. It doesn't work that way. So I'm going to take matrix A times matrix B. And I actually don't think you even have to put the multiplication symbol in there. I just do to just reiterate that's what we're doing. And there we have 39, -3, 3, 37, 39, 25. Cranks out that for you. Okay. If you by chance put those in there and didn't look at the dimensions beforehand and you just had it do the calculations, if the dimensions don't match, it's going to give you an error and say dimension mismatch. That's what it's going to say. Like, you've already got matrix A and matrix B typed in, or you want to type in matrix B. All right, so to type in matrix B, you're going to go second matrix, go over to edit, and then arrow down to matrix B and hit enter. And it should take you there. Not taking you there. Okay. Oh, you got to get out of here first. That's what it is. Second. Everybody else okay? Yes, sir. Yep. Main screen, second. Always, guys, with the graphic calculators, if you need to get back to the regular calculator screen, hit second and then mode, and that gets you there. That's kind of like your starting place if you get kind of lost in moving around. Second mode gets you back to the home screen, and then you can usually find your way from there. Okay. All right. Matrix multiplication, scalar multiplication, addition, subtraction. What's the difference between matrix addition and matrix multiplication other than the operation?
Basically, non-matching matrices can be like non-matching matrix dimensions can be used together.
For which operation?
For multiplication. So 2 by 2 fractions can be used with 2 by 3 matrices.
Yes.
2 by 2, yeah.
All right. So what Ted said, addition, they got to be the same size. If they're not, you can't do it. Multiplication, they don't have to be the same size. What has to match for multiplication to work? The middle two on the columns from the left one matching the rows from the right. Those two numbers in the middle. If you write the dimensions there, those two numbers in the middle better match up. If they don't, then you know you can't do it. Okay? All right. All right. That's it for today. On Khan Academy, you've already got some assignments given to you there if you wanted to start on them. Matrix dimensions, it's just a little exercise on making sure you're getting the dimensions correct. The elements of those, it's going to ask you which one, the elements match up, that sort of thing. Adding and subtracting, matrix equations with addition, subtraction, multiplying by scalars, and multiplying matrices. So exactly what we've been doing there. Okay, so you can start on those if you want to. Yeah.